Hello everyone. Uh, Let me see if this is working. I will wait for some moment to see if we have the YouTube live up and running. Yep, I think it. I hope everyone is doing good and you guys are having fun, or at the same time you're learning something out of this assignment. So in this session, I will be going through assignment 3, which is BaseNet. Uh, Basically, in this session, what I would like to discuss is the details of the assignments, and then I will go through over some of the key concepts and some of the uh, projects, the detail of the projects. I won't be going over in detail about the concepts that has been discussed in this assignment, because that is where you will refer to the classroom notes and the lectures and the textbook, but I will try to touch upon the topics that you are expected to know to solve this assignment. Then we'll go through the scoring of this assignment, and then we'll look over the testing, how in the local and how in the grade scope the testing you can do. And then finally we will close the session with some of the suggestions that I would like to give you guys. Okay, so let's start. So the assignment detail is basically, so the assignment is released in 27th of September, last Sunday midnight. I hope you all have access to the assignment GitHub repository, and also you should have access to the grade scope. And the assignment end date is 10th of October, so be sure to finish it on time. And if you need any special accommodation or assistance, please reach out to HATTS as soon as possible. The lecture material covered in this is the module 5 and 6, and the probability chapter in from the textbook. So let's go through some of the details of this project. So basically in the BaseNet, so I'm not sure if you guys are able to see the full screen and the view. Let me just check if you guys. Okay, see. Okay, so I'm not sure if you guys are able to see the full screen, but anyway, I will go ahead and see if it can be fixed later, because I think in my phone it looks like I'm not able to see the full picture of the slide here. But let me see if I can fix it. But for the BaseNets, yes, as you know that BaseNet is basically a graphical representation of random variables, where each node in the graph represent a random variable, and there is a set of directed link notifying cause and effect, or a parent-child relationship. So for example, in this figure there is a direct relationship between burglary and alarm. So if there is a burglary that happened, which is a cause, and it can affect an alarm to ring. Similarly, earthquake is a cause. If it happens, then it can cause, it's a parent-child relationship. And each node in this can be represented using conditional probability distribution. So for example, the probability of any node in a graph is what is the probability of any node in the graph given the parents or given the cause. So what is the probability that the alarm will ring given the burglary has happened, or what is the probability that alarm will ring given the earthquake has happened. So all these things which can quantify the effects of parents on the node can be represented using probability distributions. Some of the definitions I think you should be aware of is the prior probability, posterior probability, marginal probability, and conditional probability. Prior probability is basically probability of an event that will happen before you even take new evidence into account. Posterior probability is of an event, it's a probability of an event that happened after all the evidence has been observed or collected. So, and this evidence can be summarized in the likelihood function. So for example, if we talk about the same burglary or alarm note, what is given the burglary has happened, or given the earthquake has happened, these are the evidences that you have observed. What is the probability that alarm will ring? So evidence is basically, so posterior probability is basically where you calculate prior probability plus a new evidence that has been given to you, which is also known as a likelihood function. Then there's a marginal probability, that probability of one variable irrespective of the outcomes of the other variables. For example, probability x is equals to a for all outcomes of y. So irrespective of what happens to y, what is the probability that x equals to a? So for example, in the Bayes-Natt graph, what is the probability that that John calls given burglary has, what is the marginal, if we talk about what is the marginal probability that John calls, it means that considering all the situations, what is the probability that John will call? So you have to take into account burglary has also happened, earthquake has also happened, and alarm has rung, and what is the probability John calls? So when you consider all the possible outcomes, what is the probability that A will happen? So that's your marginal probability. And the conditional probability is basically the likelihood of an event to occur based on the occurrence of your previous events or outcomes. Then Monte Carlo simulation, that is also something that you need to read about or learn about, which is basically a method for estimating the value of an unknown quantity using the principles of inferential statistics. Now what is an inferential statistics is basically you have a population which is a universe, which is a set of examples basically, and you pick a sample. Sample is basically a proper subset of that population. So if I have to give you an example of this, I would say is that consider an example of a game of chess. So the population in the game of chess is basically an infinite number of games that can be played between two players. Now among this infinite number of games, you pick a proper subset of from this population. From random sample that you pick, or the sample that you pick, it tends to exhibit the same behavior or the properties as the population or as the whole universe will in itself will show. And Monte Carlo Markov chain is the model which describes the sequence of all the possible events where the probability of each event depends on the state achieved on the previous events. Okay, let me quickly take a small break to see if you guys are able to view the screen properly. Let me just go this and see if why I'm not able to see, why you guys are not able to see it. Oh, I think, okay, oops, okay, I think you should be able to. Okay, sorry about that. So yeah, so the second part is in the Monte Carlo Markov chain is basically sampling. It's based on sampling. So there are multiple algorithms, but the main algorithm that you will be focusing on this is basically MH sampling and Gibbs sampling. MH sampling, you basically determine the posterior probability without knowing the normalizing constant. You sample all the variables at a time, meaning instead of selecting a single non-evidence variable to change, you select all of the non-evidence variable to change. So if so you basically uniformly pick all the non-evidence variable at a single time, and then and let's say you pick that sample by picking randomly. Instead of immediately accepting it, you need to check, whether you want to accept it or reject it. And the way to check it or reject it is using the acceptance ratio that you guys probably have learned in the lectures. And the acceptance is basically a pseudo number with the likelihood of acceptance getting higher if your acceptance ratio is higher. And if you, let's say if you accept a sample, uh, then you basically return the new sample that you just picked up. You basically wrap it around into a tuple, and then you return it. And if you reject a sample, then you don't have to return the sample that you basically picked it randomly. You, instead of that, you will pick the previous sample, or you will pick the original input list as a tuple. Gibbs sampling is it's basically a special case of MH sampling. It is applicable when the joint distribution is not known explicitly or is difficult to sample directly, but somehow you have access to the conditional probability for each variable, and it's easier to sample. So like in our case, in our example in the assignment, you will have access to the conditional probabilities, and so you can use Gibbs sampling also. And you sample one variable at a time. So in image sampling, you are sampling all the random variables at a single time, but in Gibbs sampling, you basically sample a single variable out of your whole list of random variables once at a time. Okay, so let me go through the uh, repository, GitHub, and so this is the GitHub repository. Okay.